Hey guys, it's Dr. B here. Miss y'all. Hope y'all are doing well and keeping safe. So this video is a demonstration for one of the topics we discussed in the lecture about percentages, the types of percentages, the mass to mass, volume to volume, mass to volume, etc. Well, I guess those three. So you may notice that I have a Harry Potter background. I have the Triwizard Cup. This actually is acting as my light source for this. I don't have like a heat lamp on me. So density. Density is an intrinsic property, meaning it stays the same no matter what. Regardless of how much you have of something, it's going to be the same. So we are going to test that. I'm going to show you how it looks through a density demonstration using different types of soda or Cokes, whatever. All right, so this container, it's the same container, same water. This is just from the tap. So this is just tap water, regular tap water. So this is going to be my control variable. Same water, same container, same person doing it. Maybe that's probably it as well. So we're going to test this. So let's test Diet Coke and regular Coke first. So these are both Coke products, so control variable. These are both, let's see, 7.5 fluid ounces, so control as well. So what should happen here is that whichever of the two has a density that is less than the water, it should float. Whatever has a greater density or higher density than the water, it will sink or it'll be a little bit lower. So I'm going to put this in the same way, like this on its side, to try to minimize the amount of oxygen that may push up the cans. Alrighty, so you can kind of see in the video right now, the Diet Coke is a little bit above, so it's floating a little bit more than the regular Coke. So that means that Diet Coke has a smaller density. All right, so let's try this again, but let's do 2 regular sodas, meaning not diet, and let's see how they behave. So I'm gonna dry this off as much as I can. So Dr. Pepper and regular soda, regular Coke. Let's see what happens. Both 90 calories, maybe that helps. 7.5 fluid ounces for both of them. Let's try this out. Alrighty, you can see that the Dr. Pepper actually is more dense than the regular Coke. So even though I try to put it on its side, both of them drop them at the same time, etc., you see that the Coke actually is a little bit higher than the Dr. Pepper. So that means, looking at this, our Dr. Pepper is more dense than the water and more dense than Coke. Maybe we can figure out why. Maybe one of y'all can, find some information, maybe explain why it's denser than the Coke. Maybe it's something else. Maybe we're supposed to get a different value, I don't know, or different results. But for the most part, as you can see, if I just put this Diet Coke in here on its side as well, it still floats, and looks from my angle, you can see that it's actually higher than the Coke still. So alrighty guys, you all have a good day. Review your notes, review the slides, review the video, etc. If you have any questions, let me know. Bye guys.